Hey guys, welcome back to my channel. So today I will show you how to prove about this one. The first thing we need to use about binomial expansion. So I will put about 1 plus s to the power of n. So about binomial expansion, that should be like this. So I will start at the first term, that is about n number 0, and this one we have 1 to the power of n. About s, that is about 0. So the next term, that is about n number 1, and this one we have 1 n minus 1, and s now we become to number 1. Now we go to the next one, n number 2, and we have 1 to the power of n minus number 2, s that will go to number 2, and so on until we have n 1 to the power of 0 and s to the power of n. And this is about binomial expansion. Now we need to do the derivative for the both sides. So if we do first the derivative of this one, we got n multiplied by 1 plus s to the power of n minus 1. Later that we need to do first the derivative of 1 plus s. This one you got number 0. This one we have number 1. So we can simplify like this. So on the right, this one that is about number 1. This one that is about number 1. So that means this one that is about the constant. So you got number 0. So this one we have number 1. After we do first the derivative, this one that is about 2s. So if we continue, we have 3s squared in here. This one that is about 4s to the power of 3 until we have n. So this one that is about ns to the power of n minus number 1. So after we got this one, we put about s equals to number 1. Go in here, 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 and here. So 1 plus 1 we have number 2. This one we keep the same. This one we have number 2. The next one that is about number 3. And so on until n. And this is the final answer. This is the end. Thank you for watching.